Dear students, Assalamu alaikum. My name is Nazir Ahmed and I am working as Professor of Chemistry at Government Degree College number 1 DA Khan. From today I am starting online classes for first year F.Sc so that the students may learn chemistry by staying at their home and be safe. The first chapter of first year F.Sc is stoichiometry. The first chapter of part 1, chapter 1 of part 1 F.Sc is stoichiometry. Stoichiometry. What is stoichiometry? First of all, you would ask the question that what is meant by chemical reaction. We start with the term chemical reaction. Chemical reaction is a process in which one kind of substances are converted into other kind of substances. One kind of substances which are known as reactants are changed into other kind of substances which are known as products. Reactants are converted into products. For example, carbon burns in air to produce carbon dioxide. Now it is a chemical reaction that carbon burns in air to produce carbon dioxide. Or sodium reacts with water to produce sodium hydroxide and liberate hydrogen gas. The second term, these are also known as chemical reactions. Carbon burns in air to produce CO2, or sodium reacts explosively with water to produce sodium hydroxide and liberate hydrogen gas. There are many examples of such reactions. Second term which is generally used is known as chemical equation. We can represent the chemical reaction in terms of symbols and formulas, and this representation of a chemical reaction in terms of symbols and formulas is known as chemical equation. Chemical equation is the representation of a chemical reaction by symbols for elements and formulas for compounds or molecules. The above reactions, the two reactions which we have mentioned, can be represented by chemical equations. Reaction 1 can be represented by the equation C plus O2 CO2. Solid carbon dioxide react with gaseous oxygen to produce gaseous carbon dioxide. The physical states are also written in the reaction. Similarly, solid sodium 2Na, it reacts with water 2H2O, which is in liquid state, a liquid phase, to produce 2NaOH, sodium hydroxide solution. AQ means aqueous solution plus liberate hydrogen gas. Now these are the chemical reactions and these are the corresponding chemical equations. So in any chemical equation, for any reaction, there may be different relationships present among reactants, between reactants and products. For example, let us consider reaction number 2. Reaction 2 is between sodium and water, and we have written it as 2Na plus 2H2O, 2NaOH plus H2. Now the different relationships which are present in this equation, in this chemical equation, may be mole relationships. Mole relationships. For example, it shows that 2 moles of sodium react with 2 moles of water to produce 2 moles of sodium hydroxide and 1 mole of hydrogen. Now these may be particle relations. These may be relationship between particles. For example, 2 atoms of sodium react with 2 molecules of water to produce 2 formula units actually, or we can write they produce 2 formula units of sodium hydroxide, as it is ionic compound. Ionic compounds consist of formula units and 1 molecule of hydrogen. The third type of relationships which may be present in these equations, they may be mass relationships. Mass relationships may be present. We know that the atomic weight of sodium is 23, so 23 multiplied by 2, 46 grams of sodium react with, we know that the atomic weight of hydrogen is 1, 1 into 2 plus 16 is the atomic weight of oxygen, 18 into 2, we have 36 grams of water. Sodium is 23 plus 16 plus 1, 40 multiplied by 2, 80 grams, and H2 is approximately 2 grams. So it shows that 46 grams of sodium react with 36 grams of water to produce 80 grams of sodium hydroxide and 2 grams of hydrogen. All these relationships which are present, the study of the relationships, different relationships which are present in balanced chemical equation is known as stoichiometry. Stoichiometry is the study of relationships, study of various relationships which are present in balanced chemical equation. These may be either mole relationships, or they may be particle relationships, or they may be mass relationships. So stoichiometry deals with the study of relationships. So stoichiometry is a type of quantitative chemistry. It deals with quantities. Quantitative chemistry. We are discussing Avogadro's number and mole. What is the need for introducing mole? We know that for measuring different quantities, we use different units. If we have a small quantity, we use a smaller unit, and as the magnitude of quantity increases, the size of the quantity increases, we use larger units. For example, let us take an example. The mass of gold is usually taken in milligrams. The mass of sugar is expressed in kilograms. The mass of wood is expressed in moles, and the mass of steel is expressed in tons. Likewise, if we are considering length, the length of pen may be expressed in centimeters. The length of a door or room is expressed in meters. The distance between two cities is usually expressed in kilometers, and oceanic distances are usually expressed in nautical miles. Similarly, when we come towards counting, we use different groups in ordinary life and we give them different group names. Like we use the term dozen. A dozen is a group of 12 similar things or objects. Score is a group of 20 similar things or objects. And score and gross is a group of 144 similar things. Now these groups are known as usual groups of counting, and these groups can be used easily for macroscopic objects which can be seen with naked eye, like tables, chairs, pens, boys in a class. But when we come towards microscopic particles like atoms, molecules, ions, formula units, then these units cannot be used. These units cannot be used for counting microscopic particles like atoms, molecules, ions are formula units. And the reason is that these microscopic particles, they are present in countless numbers. For example, if we draw a line with pen which is 1 centimeter long, if we draw 1 centimeter long line with a marker or pen, this 1 centimeter line will contain 10 raised to the power 8 atoms of ink, or they will contain 10 crore atoms of ink. No, it is very much difficult to count these atoms or molecules. Therefore, according to general rule, that as the size of the object or the number of particles, the number of objects increase, we need a very large unit. We had given many examples. Now, in this case, we also need a very large unit for counting, and that unit is known as mole. So, mole, what was the need for mole? Mole was required to count microscopic particles which are present in very large numbers. Now the question is, how many particles will constitute one mole? How many particles will be present in one mole? Now there are two definitions of mole, an old definition and a modern definition. The old definition for mole was mole, therefore we can say that mole is a counting group used for microscopic particles, and it is one of the 7 basic units of the SI system. One of the seven basic units of the SI system, of the System International. There are 7 units in System International. Unit of mass, unit of length is meter. First unit of length is meter. The unit of mass is kilogram. The unit of time is second. Fourth is the unit of current, ampere. Fifth is the unit of light intensity, candela. Sixth is the unit of temperature, which is Kelvin, and 7 is the unit of quantity of substance, which is called mole. Now there are 7 units in the SI system and mole is one of them. The old definition of mole, which was initially proposed, is that if we have, let us suppose we have 12 grams of carbon 12. Carbon has three isotopes, carbon 12, carbon 13 and carbon 14. If we have carbon 12 and we have a mass of carbon 12 which is 12 gram, and let us suppose it contains some number of atoms. Carbon is composed of atoms, and we suppose that the number of atoms which are present in carbon, let us suppose that this piece of carbon contains X atoms. It contains X atoms. Now if we have other substances, like we have a piece of iron, we have water present in a beaker, we have a crystal of sodium chloride, NaCl crystal. No, iron contains basic particles, elementary particles of iron are atoms. Iron is composed of atoms. The elementary particles of water are molecules, and elementary particles of sodium chloride are formula units. According to old definition, the amount of a substance which contain as many elementary particles as there are atoms in 12 grams of carbon 12 is considered 1 mole of that substance. The amount of a substance which contain as many elementary particles as there are atoms in 12 grams of carbon 12. So 1 mole of iron means that quantity which contain X atoms of iron. The amount of substance which contain X atoms of iron, because there are X atoms in carbon 12 and it also contains X atoms, thus it is called 1 mole of iron. 1 mole of water means the quantity of water which contain X molecules of water, which contain the same number of molecules as there are atoms in 12 grams of carbon 12, and it is also called 1 mole of water. Likewise, 1 mole of sodium chloride, if it contains X formula units of sodium chloride, then it is also called 1 mole of NaCl. Now the question was, what is X? How many carbon atoms are present in 12 grams of carbon 12? And this quantity X was determined by a scientist whose name was Amedeo Avogadro. Through the electrolytic process, he determined that 12 grams of carbon 12 contain 6.022 into 10 to the power 23 atoms of carbon. This number is called the Avogadro's number, because it was determined by Amedeo Avogadro, and it is denoted by N or Na, and sometimes it is also denoted by L. Sometimes, very rarely, it is also denoted by L, but generally it is denoted by N or Na. Therefore, you can say that mole, what is mole now? Mole is the quantity of any substance which contains 6.022 into 10 to the power 23 elementary particles. So 1 mole of iron will contain 6.022 10 to the power 23 atoms of iron. 1 mole of water will contain 6.022 10 to the power 23 molecules of water, and 1 mole of sodium chloride will contain 6.022 10 to the power 23 formula units. Inshallah, the lecture will continue in the next video.